Hi, everyone. I am Scott Lewis, and this is your virtual star party for March 24th, 2013. We have a great show for you tonight. As showing earlier, we have David Dickinson out of Florida showing us Jupiter.
Okay.
And we also have with us Gary Ganella out of my backyard. Well, close enough, right?
Close enough.
And we also have Peter Lake with us from Australia
Hi,
and
Scott.
New Mexico, right? At the same time?
Yes, correct.
Quantum Peter. Awesome.
On my lunch break, yes.
On your lunch break, even. And we also have we have Roy Salisbury.
Hello.
Hi, Roy. And with us with commentary tonight is Ray Sanders driving Stellarium.
Hi, everyone.
And our PhD astronomer, Dr. Thad Szabo from Cerritos College.
Good evening.
Hi, everyone. So it's been a crazy week. We've had a lot of hangouts so far with science today for Science Sunday. It's been really fun. And we were going to stay on the same task of keeping our virtual star party, even though Fraser is out invading the United States somewhere. He's somewhere in the northwestern U.S. We haven't tracked him down yet. So if anyone sees a tall, balding Canadian, go hunt him down.
Can we set up something, Scott, kind of like the Santa tracker? We can do the Fraser
We totally
tracker.
should. Absolutely. Go. This is Fraser, eh? And we'll just find him on Twitter. It'll be great.
Shouldn't you just look for like a large convergence of social networking, like pings and packets that aren't going toward like Microsoft up there or something?
Right,
Then it's got to be
exactly.
Fraser.
It must be Fraser. You know, there's many bags of milk references and Mounties, and we don't know what's happening. But
Well, he's from the wrong part of Canada to be bringing maple syrup, right?
I don't know. I'm sure they have maple syrup somewhere in Vancouver. So looking here, I mean, right now we're pulling up Jupiter first with David Dickinson because it's setting, and so it's going to look a little bit more wavier and soupy because he's in Florida for one, but also since you're looking through more and more atmosphere.
We're beginning to start to look through more air mass now. It's only about 20 degrees above my local horizon here. We'll probably, in a few more virtual star parties, we probably won't be able to get Jupiter, at least not from this location.
Right.
And I'm in the Eastern time zone. So.
Eastern time zone?
Yeah.
Like daylight savings time?
Actually, it's daylight save. As somebody corrected me the other day, it's actually daylight saving time.
Oh.
I actually wrote in a post with the daylight savings time, and I had a commenter say that actually it's daylight saving time.
Actually.
Yeah, it's kind of one of those things like ATM machine and PIN number.
Right. All right, well, I'm going to move over to Gary's view here. And what do you have for us tonight, Gary?
This is the Flaming Star Nebula, and I don't think I've ever imaged that before. It just came up in a club meeting that we had Friday night, a guy that was pointing out things in the sky, and I don't recall having seen it, so I thought I'd point at it and put it up here. And somebody like Thad can tell us what it is.
Someone like Thad, or Thad himself.
Or someone like me. Can I find my clone around here somewhere? So Flaming Star Nebula. Actually, I don't know how much I've known about this one. But again, if we're shooting with H alpha, then what we're seeing here is hydrogen. And now we know, because of Planck, that hydrogen is more of the universe than we thought before. Instead of thinking it was a little less than 4% of the universe, now it's just a little less than 5% of the mass in the universe is hydrogen. All getting lit up by a star here in the middle. And I'm guessing with the idea of flaming star, that this is most likely some sort of variable star bit in the middle, maybe. Again, not terribly familiar with the object, but I'm thinking when I hear flaming that I'm thinking variable. Or is it just that it looks like a flame? Is that it kind of looks a little bit like a flame here?
Yeah, it kind of does.
I couldn't find any other designation for it. Let's see.
IC405 is what it's showing in Stellarium for me.
Okay, because I'm showing it source catalog as a core SDB. Then common name. What does that say? I'm looking up in my common non-stellar. So it's
Sure.
core
IC405 or Caldwell 31.
Okay.
And for those who are interested in trying to find the Flaming Star Nebula on themselves, I've pulled it up in Stellarium. It's in Auriga, as opposed to Aruba. It's in Auriga.
Or arugula. It's the salad in the sky.
Ooh.
Okay, so this is it. It surrounds the irregular variable star AE Aurigae. So, so there we go. So there is a variable star in the middle. So that would add kind of maybe a bit of flickeriness to it. But I've got to see is there a period on that variable star? Because that would tell us how long to expect one flicker of the flame to last. But it's an emission and reflection nebula. So right now, because of having hydrogen alpha, we're just getting the emission portion. But if we could do a color photograph, like with a color CCD or with a DSLR, then you'd be able to see some bluish regions from dust in there as well. So this is actually fairly bright. That's surprisingly bright. It's magnitude 6, meaning that if you were under dark enough skies, like somewhere like Death Valley, for instance, you'd probably be able to see this naked eye.
That's really awesome. So just a quick reminder, everyone, that if anyone has any questions or comments or even requests, you can go ahead and leave them in the event page here on Google Plus or out on any of the shares. So also, if you guys could, please feel free to share out the Hangout to everyone in your circles to help spread the astronomy out there. We'll also be on Twitter using the hashtag #StarParty. So if you want to make any of your questions or comments, we'll be out there. And also on YouTube, we'll be able to see those as well. So I'll be checking out those comments and questions. And feel free to make some requests. So moving along, we're going to go over to Peter. And what do we have here, Peter?
So one of our favourites, M1. So just got to zoom in on that a little bit for you. Here's my zoom button here. So it's a Crab Nebula. So it's a lovely, the first one in the Messier series. So it's
very nice.
It's very good.
All right. So this is a supernova remnant. So we had a massive star come to the end of its life. It would have been about 7,500 years ago, but because this object is 6,500 light years away, follow the math here, that means that supernova showed up in our sky about 1,000 years ago, and the ancient Chinese astronomers recorded, Arabic astronomers recorded it. People in Europe went, this doesn't feed me or keep me alive. I'm going to go back to plowing fields.
Right.
But it's apparent that probably some of the tribes of Native Americans in the Southwest U.S. also did a kind of cave painting of this bright star near the moon. It was visible during daylight for at least a month when it first blew up, and now 1,000 years later, this is what we see, this expanse of hydrogen and other elements that have been dispersed throughout space because of this massive explosion. There's a neutron star buried deep in there somewhere, and so we get pulses from it as a pulsar. So yeah, pretty amazing object, and again, it's a recycling method. This is how we get elements back into the universe to potentially make new planets, new life, and just kind of continuing the cycle here as long as we have these ultra large stars. Nucleosynthesis, and not just Big Bang nucleosynthesis. Right? We get elements heavier than oxygen this way. So.
Yep. Now I'm going to throw up. You mentioned supernova, so. Very quickly throw up M65, but it's only 15 degrees from the moon and just can't do it. So
moon?
if you just I could probably zoom in, but you can't even see that it's a galaxy. So it's just not doable. But I think Roy's got one from last night. He's going to share with us. But these Type 1 and Type 2 supernovas go off almost every day now. I think, Tad, there's about 400 a year detected in the Central Bureau for Astronomical Telegraphs. I think that averages out at about one star blowing up every day, which is quite amazing.
Right, and I mean that's in the magnitude range where we do frequent scanning, and from Earth's surface, that's typically the cutoff is typically about magnitude 22. So there are likely far more going off, but because of even with no light pollution whatsoever, you have limitations due to air glow, aurorae, just other effects from having an atmosphere that limit the faintest ones we can see. If we had, say, a dedicated sky survey telescope in space, we'd be seeing hundreds per day, most likely, from some of the most distant objects in the universe. But again, that we don't have any telescopes in space that can survey that large of the sky at that deep a magnitude and still give us good photometry. So, future project.
More science, please.
More science.
More science.
So Thad, real quick, what's that space telescope that does the X-ray and the gamma, where it detects the X-ray and gamma ray bursts and then slews to the location?
Swift.
Swift. Okay.
Yep, Swift.
We just had a presentation on that Friday.
Nice.
Nice, yeah. It's amazing what that's found, though, and also just a little bit of the history of even finding gamma ray bursts, that it was an artifact of the Cold War, of U.S. satellites monitoring the Earth's atmosphere and monitoring the Earth's surface for activity from the former Soviet Union, and they're like, hey, there's bunches of gamma rays coming in burst from the opposite direction from the Earth. And so that was the first indication that you had these incredibly energetic processes that were flooding space with these essentially beams of radiation from core collapses of very massive stars, or combining neutron stars that spiral into one another and give off one of these jets. So but yeah, it's the Swift telescope, and it can slew. I forget what the slew rate on it is, but it can essentially, as soon as it gets a detection, it can get its cameras over to it typically within a few minutes.
It's actually something about 19 seconds. We had a PhD from Italy who's worked on that and been studying it. She's been in the States for 7 years. I don't remember her name, but she gave the presentation, so that's kind of fresh.
Okay, good. Thank you.
Welcome.
So, but yeah, 19 seconds, and it will also send information about the location down to Earth-based observatories. So if there's anyone that is not currently dedicated to time for somebody else's project, that they can start following up on that location in the sky immediately. So
awesome. I just love all the I can't wait for JWST, but all just the awesome space telescopes that we have out there that are able to look in different ways. You need to have specific equipment to look for specific things, and so we have SOHO up there for specific mission. We have Hubble that's able to do specific wavelengths, and we have you can't just send a regular telescope up to look for X-ray. You need to have a specific detector that is able to interact with X-ray radiation that way. So I do love just the new ways of everything going up. James Webb is going to be in infrared to look at these stretched out wavelengths of light hopefully from the dark ages, which I'm excited to see.
Right, and the geometry for these other telescopes, I mean, you think optical telescope, well, there's a big mirror at one end and it's going to focus light to wherever your camera or eyepiece is. For X-rays, they actually have to put the mirrors in at kind of an oblique angle and have the X-rays kind of hit off of it at these very kind of very shallow angles to come back to where they would be focused. So yeah, very different type of structure and setup for X-ray observatories or X-ray telescopes versus optical.
Right.
Well, and speaking of optical telescopes, just on a point that Scott was making real quick to kind of bring the science in here, speaking of different telescopes for different purposes, one telescope that I'm continually amazed by is Kepler. The astounding number of exoplanets that Kepler has discovered in the tiny, 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 tiny patch of sky it looks at. And, if we've got beautiful images that we get from Hubble, and Hubble has been around for so many people's entire lives and then more. But I think Kepler really, going into the history books of just making, landmark discovery after landmark discovery. And again, purpose-built telescope. It was designed to find planets.
Right, but I mean, despite even in addition to the 2,800 plus exoplanet candidates it's found, it can do astrometry, so it can potentially look for parallax. So if you're seeing any of these stars shift from one side of Earth's orbit to the other side of Earth's orbit, this gives us distance measurements to these stars. Other variable star observations, so things that aren't regular, where it's like, okay, planet just moved in front. oh, there it did it again, right? Something where
Right.
you get things that are slightly less regular, things like astroseismology, finding candidates for starquakes. Because it's such a sensitive detector on there, it can register these tiny, tiny changes in the amount of light, but give us good signal to noise on them, meaning you can actually pick out more candidates than just exoplanets. You can find all this other potential astrophysics from Kepler. So designed for one purpose, but it's like, hey, can we use it for this and this and this? Yes.
There's so much science to do. Let's find more science to do with it.
There we go.
Well, of course.
So, Roy, what do you got up here, Roy?
Well, I was just trying to bring in on the mention that Peter made on the supernova.
Mhm.
What's showing here is an image that I took last Monday without the supernova. So the supernova, I don't know if you can see the crosshairs here. It would be right in the right-hand side of the galaxy.
Uh-huh.
And then if you look at the one I took 2 nights later, which should be this one. Is that the right one? Yeah.
Yep.
Right there, you can
Oh,
see the
that's right.
supernova.
Oh, nice.
Awesome.
Oh, yeah.
Awesome.
So I missed it by 1 night.
You still got it, though.
Yeah, but I wanted to get it when it was just like 1 image before and 1 image after within 15 minutes, but it didn't work.
Well, you know what you need to do? You need to do more stargazing, Roy. You need to go out there and do more.
Or
Yeah,
get a TARDIS.
It'd help if there wasn't clouds over
Yeah.
everything.
Yeah.
Yeah.
So
It's only
I've had
15
this
degrees
happen.
from the moon tonight, so it's a very difficult get tonight. But this was last night. This one's rotated 90 degrees to Roy's, but you can see this was taken on my telescope last night by Ian Musgrave, who's an amateur astronomer in Adelaide.
Oh, nice.
So that's. But tonight the moon's just too close. So.
Yeah,
The other
I
thing
ain't
is
getting anything tonight.
for anybody else out there who does any astrophotography or any of the guys who are running scopes here tonight, with the supernovae you get a light curve, and so in the first week to few weeks after they first appear, they're going to continue to brighten, and then after that they'll start to fade out. So the more measurements of it we can get, the better the data we have on understanding what the processes are with this particular supernova. So any night you can get out there and shoot it, go do so.
Actually, it was my plan this week to do the Leo triplet. So
Good plan.
starting from last Star Party, I went and said, all right, I'm going to do the Leo triplet, and it just so happened that Tuesday or Wednesday or whatever it was cloudy, and I couldn't do anything, and now the moon's too bright to do anything. So I
Oh, the
stopped imaging
moon.
it.
Yeah.
All right. Well, let's go ahead and move back over to Gary, because Gary actually has not only going to be showing us something, we'll be sharing out some things as well with this image too for the public.
Yeah, this is 10 seconds of the Orion Nebula and hydrogen alpha. What I'm going to do is I'll post the link, but I'll put 10-second photos for both hydrogen, oxygen, and sulfur, both in JPEG and the standard FIT format, if you can handle that. And then I'll do also a 1 minute of each one of them that I'll post up if anybody wants to play with combining them. But this is a 10-second. And let me do this right here, and you'll see an oxygen.
Oh,
the
nice.
difference of change, that's an oxygen 3, and I'm doing the sulfur right now. I got to refocus for sulfur.
So
That's the oxygen 3.
So Thad, when we're talking about things like hydrogen and oxygen and sulfur, those are things we commonly think of as far as just being elements on Earth. But what are we talking about? We're talking about astronomy and light and things like that.
So for them to have this kind of glow, you have to have the electrons get excited. Okay, but excitation in this way means that you dump extra energy in, and it's at just the right wavelengths for the electron to move from a lower energy level up to a higher energy level. And on the way back down, it's going to emit a certain characteristic wavelength of light. So for hydrogen alpha, this is actually likely electrons recombining with hydrogen, and then on their way back down to the ground state, give off this characteristic red light at about 653 nanometers, if I remember correctly. When we're talking about oxygen, you're talking about oxygen 3, and so this is not like ozone, which is O3. This is oxygen 1 means no ionization. Oxygen 2 means, okay, well, we've got 1 electron knocked out. Oxygen 3 means we've got 2 electrons knocked out. And so it's going to glow with a particular blue-green color, and so that's what this filter that Gary is currently showing shows. And then with the sulfur, it's sulfur 2, so it's ionized once, and that glows in kind of a reddish color for the line that we look for in sulfur. So all of these elements are present in space, especially in a nebula, especially if you've had these supernovae blow up. If you're looking at the elements that have been present since the Big Bang, that's hydrogen and helium. So stars had to form first to produce heavier elements.
Maybe a little lithium too, because you got to relax.
Tiny little bit of lithium. Of course, it's important for astrophysics to determine exactly how much that tiny amount is.
Right.
But all these, any elements up to oxygen formed in stars like our sun, anything heavier than oxygen forms in these type 2 supernovae. So looking at that star that blew up in M65, or looking at the Crab Nebula, this is how these elements heavier than oxygen make it back into the universe. And we're looking at the picture in sulfur with the Orion Nebula. This means not only are there new massive stars forming there now, stars had to have blown up. Massive stars already had to have blown up to flood that area with enough sulfur to glow the way that it will show up in these images that Gary's capturing.
Okay, and here's a 10-second in sulfur, so I'm going to switch it right now.
Oh, nice.
So that's 10-second in sulfur, and then I'll post all these so somebody can play with combining them.
Beautiful.
Excellent.
So
Yeah.
that you can really see the difference in structure.
Absolutely. You're seeing the different type of light being emitted from it. Love that. So we're going to take a look at the bane of our existence tonight over on David's screen. So this is what we've been shaking our fist at.
There's a nice view right on the Terminator there.
Yeah, and actually I love the
there's a central peak.
There. Yeah.
There's a central peak where it's just starting to catch the sun. I like how you can see the shadow back there. I think that's
awesome.
Philolaus is the name of that crater, and John Herschel is the name of the crater in the front, with a secondary inside it.
You can actually see the shadow cast on the back wall of the rim.
Yeah.
Yeah, from the central peak. It's really terrific 3D feel here.
Either that or it's a monolith down there.
Looks like a sundial.
Yeah, that's my secret moon base, David. Can you please slew away from that? I do not need people knowing where I live.
Oh, that's right. We're not supposed to. Yeah, sorry. Not supposed to be showing you.
And so Herschel's up near the northern edge of above Mare Imbrium and Oceanus Procellarum, right out, kind of out by the far western edge of Mare Frigoris, if I remember correctly.
Yeah.
Okay.
There's Iridium right there.
And Sinus Iridum, yes.
Yeah.
The Sea of Rainbows, right? And just beautiful little ring of mountains around the edge of that structure there.
I think we're about 2 days from full.
Yeah, sounds right. My students have been doing moon maps recently, so all this is quite fresh in my head. So
yes.
Moon. I always wonder if I have students who end up being more familiar with lunar geography than Earth geography after they're finished with my lab.
They should be with the moon. Come on.
Yeah.
Because if they're around long enough, the geography on Earth doesn't matter because of plate tectonics. The moon isn't going to be moving around that much anymore.
Much longer lasting knowledge.
Yeah, come on.
Well played.
I plan on living around for billions of years, so I'll wait and just watch these plates float around. We've got a quick question here on YouTube. BTL743 is asking, can we see the rover on the moon? No, not with what we have here. However,
not in my backyard.
we have dogs out here. But
actually, Scott. Oh, I'm sorry. I was going to jump in real quick and actually to that person's comment. Actually, looking for things you can see on the moon. The Lunar Reconnaissance Orbiter camera,
right.
Go ASU, has a huge library of Apollo landing sites and other areas of interest. So I can pull that URL up and give that to you in just a second.
Right, or and not only that, but with talking about the Lunar Reconnaissance Orbiter camera, if you head on over to CosmoQuest, we have our Moon Mappers program, to where you can actually be involved in doing citizen science and taking the images from the Lunar Reconnaissance Orbiter, and you could have some interesting things where you could see some of the lunar landing sites and see some of the tracks from the rovers and things like that. So I've been able to randomly get 2. While I'm sitting there clicking away doing some citizen science, I've had 2 of them pop up, which is amazing. Getting to see the images of where humans have been on this other planetary body, it's just fantastic. So though we can't see it tonight in the virtual start party, you can head on over to cosmoquest.org, participate in actual scientific research from home, and have the opportunity of seeing stuff not only on the moon, but also on Vesta and Mercury. And yeah, right now we're out of ice investigator images until we get more data in, because all of our amazing citizen astronomers, citizen scientists have gone through all that data, and we're waiting to get some more in.
Yeah, Moon Mappers is an awesome citizen science project. I got to talk about that at a convention back last fall with Pamela, and we had a lot of people jazzed, especially with the companion iPad app that takes some of the information, the cratering app that takes data from Moon Mappers and lets people work with the data further yet. So yeah, if you're interested in checking out really cool images of the moon and helping with science, like Scott said, jump over to CosmoQuest and check out Moon Mappers. If you want to check out that high-resolution imagery from the LROC, from like the Apollo sites and other areas of interest, it's www.lroc.asu.edu.
Awesome. So in the head, Peter, we're looking at this is your sky and the hideous moon.
Yeah, so just for everyone, as you know, when you're outside on a full moon or approaching a full moon, it's almost like daylight. So this is one of the darkest sky sites on the west coast of the US at New Mexico, and of course when that wonderful moon that you're looking at over here is up in the sky. It looks pretty dark in that image from David there, but when it's up in the sky,
The contrast turns way
it's
down.
almost like daylight.
Right, and you want to take that pesky, looks like you want to take a pellet gun and shoot out that light, but it's a moon.
That's why we have months,
That's
So
no
there's
moon.
a week.
That's no moon.
There's a week when
If the
astronomers
moon
can
wasn't
actually get some
there-
sleep.
If the moon wasn't there, astronomers would never get sleep.
We'd never
Speaking
have
of,
eclipses.
hey guys, speaking of moon bases, one of the people on Google Plus had a very interesting question, and I wanted to throw that in there just for the fun of debate. But they were curious, if we were to ever set up a base on the moon, is there a place that's better and why? Thad?
So I would say
On the surface.
the main thing that you always want with any base is having resources available where you are, so you don't have to keep shipping them in from somewhere else. And this on the moon would point to somewhere near one of these permanently shadowed craters. So meaning that there appear to be comets that have deposited water in these places, and so it's not going to be like, oh, just scoop it up and like snow, eat it kind of stuff. But if you have like ice frozen there, then you can always take it, melt it, have drinking water, split the hydrogen and oxygen and separate them out and have breathing, have air for breathing. So ideally you want to be someplace where you have resources available rather than having to transport them. So near the north or south pole of the moon, where you have craters that are permanently in shadow and potentially have some of these natural resources for us.
Yeah,
Now,
so Tad, I
consequently,
think
I'm sorry, go ahead.
the issue is that it takes about $20,000 a kilo to get something into orbit, and water's kind of pretty heavy, and you kind of can't take water with you on a long distance journey. You have to try and get it on the way, in inverted commas, and that's why I think the planetary sciences people who are looking at mining asteroids and so this research that Tad's talking about how much water's on the moon is actually quite critical.
Well, and one of the things interesting about bringing up water is that on the International Space Station, they've gotten really good about recycling water. I was at a great talk with astronaut Don Pettit about a month ago, and he was talking about his whole focus actually was how yesterday's coffee becomes today's coffee. And interestingly enough, that recycling
and I don't
center,
drink all of it. But
I'm sorry.
I do that too. I just reheat it, right?
no, it's a little more involved than that, Scott. But interestingly enough, on the topic of water recycling and reclamation, when you're technically on paper, the equipment's about 90 to 95% efficient, but in reality, you're closer to about 70%. So you do need to resupply water. And as Peter was saying, with water, anything that you put up into space being incredibly expensive, you want to be able to have access to those materials. So like Thad was saying, you probably want to have a source of ice that you could, crack into hydrogen and oxygen and have access to water to replenish your supplies, because your water recyclers are only going to take your stores of water so long before you need to start replenishing them. Right. One of the things I was going to say real quick is probably the worst place to set up a moon base would be on the lunar far side. Notice I didn't say dark side, I said far side. Dark Side is a great, Pink Floyd album. Far Side is, the worst place to set up a lunar base just because of communications issues. If there's some sort of a problem and everything, there's going to be those issues, and then there's actually a slew of other issues there. But Scott, you kind of dig on the whole planetary stuff. What do you think about setting up a moon base? You said that you had a base on the moon, so tell us where you put yours.
I have no comment at this time on lunar bases. And Newt Gingrich is not downstairs. But not downstairs.
I know there's been some talk over the years about doing radio astronomy from the far side of the moon, too, because it's radio quiet in that direction.
Yeah, it'd be a great place to do radio astronomy, just not a very good place to put people.
And to send my enemies. Yeah.
So the other thing with the far side of the moon compared to the near side, the Earth actually shields the near side to some degree, and this is why you see these large flat maria on the moon. Now, you look closely, you find craters there, but nothing like what the far side looks like. The far side just looks like a big mess of craters because it's turned away from the Earth at all times. Anything that's coming in at the moon from that direction is going to hit it. The Earth isn't providing any shielding. So, it is a good place to send your enemies because they're exposed to that much more risk.
Yes.
Also, just to note, the Pink Floyd album is 40 years old today.
40 years old.
So,
absolutely. Not only that, but my friend Dan just commented on it too. Yes, 40 years old today. So, even though it's wrong as far as what it's talking about, amazing album. Amazing album.
Well, there is a little snippet toward the end of Eclipse, the last song where you hear in the background, there is no dark side of the moon, really, it's all dark. Yes. And this is true. The albedo of the moon is less than 10%. The moon reflects less than 10% of the light that hits it. So yes, the moon is quite dark.
Unlike me.
If I understand correctly, that it's about as reflective as asphalt, isn't it?
Yeah, like that's correct. It's basalt.
This is the family show.
Yeah.
Right? This is the family show.
It's basaltic and volcanic material. So I mean, if you were to go, walk around on a volcano or some place that has a lot of volcanic material, you get a good feel for the basic color of the stuff on the moon. So.
Awesome. Well, I'm going to head on over to Roy's image, and what do you have up here for us, Roy?
This is M67, an open cluster.
Okay, so we have an open cluster in Cancer here, and if you get an age on this, it's between about 4 and 5 billion years old, which incidentally is also the age of the solar system. The solar system is dated to be about 4.6 billion years old. It's caused some people to conjecture that maybe the sun got chucked out of this cluster. Now, there's no definitive evidence for this. There have been too many laps around the galaxy since the formation of the solar system to say that definitively for sure, but if you look at the metallicity in these stars, meaning how many elements they have other than hydrogen and helium, and comparing that with the metallicity of the sun, it's very close. The ages are close. People think, maybe this was our, this was our home that we migrated away from.
You kids and your heavy metals.
I saw a comment here. Somebody was wondering, how often. Let's count how many times they'll say hydrogen.
Yes. Hydrogen, 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 hydrogen.
So
that would make a great drinking game.
Yeah.
Everybody drink. Yeah.
Every time we say hydrogen.
I have another open cluster here that somebody had requested, and maybe you can tell me that you can point out the difference here.
Yeah, and while we're pulling it up too, earlier today we had our hangout with the electron microscopy, and we had one of the oldest pieces of rock, which is around that time too, 4.5 billion years old, and it was awesome. So being able to see something that was as old as these objects that we're looking at, that hasn't been recycled repeatedly throughout our geology, it was just amazing. I was speechless, and I'm never speechless. You guys can know I talk a lot.
Oh yeah.
So you were poking around in some chondrules, huh?
Yeah,
Scott?
we could resolve at half an angstrom is what we were using. So we're typically resolving in much larger things here in the virtual star party. So I went to the other side of optics, and oh yeah, it was amazing. It's up on my page on Science Sunday. It's all over the place. I'll be processing the video tonight too for the Astrosphere Vids YouTube. But yeah, we have a whole lot of fun and able to pull up astronomy and things like that, and all the different sciences that are going on. They're all connected. We have a way of finding a bit of ourselves that we love in any of the sciences that are going on.
Hey, real quick on Google Plus, there's actually a question not specifically aimed at David, but since David is in Hudson, Florida, and apparently there's somebody else in his town who wants to know: is there an astronomy club in your town, David? Is there some way for people near you to get involved?
I just came back off mute because I was cleaning the fog off my telescope. Yeah, in Starkey Park in Newport Richey, a bunch of us get together. It's not really a club per se. There is a club down in St. Pete area, but a bunch of us just get together usually when there's not a full moon or a near full moon, like tonight on Saturday night. We just do public viewing in the Starkey Park area in Newport Richey. I think, as a matter of fact, this coming Saturday we're going to be out there. So that's maybe about 10 miles away from where I live. It's in the northern Tampa Bay region.
All right, cool. Daryl, if you were watching the comment that you were making on Google Plus, David just gave some great information on how you can get involved in astronomy in the Hudson, Florida area. Thanks for the question, by the way.
Yeah, if they know the local area, most people know where Starkey Park is. That's a pretty common local park area, but it's a lot of fun to sit out there and show people stuff.
Absolutely, having star parties are great, and not only virtual ones, but being there and looking with your eyeball. We had that chance down at South by Southwest, and was able to not only have our show, but we had a bunch of telescopes that were brought down there with the James Webb Space Telescope model, and it's always nice, even though I do get to work with you guys every week and look through your telescopes virtually. It's still putting your eye up to the eyepiece and catching those photons with your own retina is always good too.
So
Yeah,
Roy
one of the
brought up
things-
this.
I'm sorry, go ahead.
Just wonder, because I mean we had mentioned Roy bringing up another star cluster here,
Yeah.
and then kind of got away from it. So just to get back, since he's had this image up here for a little while, this is M44 maybe.
Yes.
Yes.
Okay.
I know those were requests from earlier.
All right.
Yeah.
So yeah, this is the Beehive cluster. This is a naked eye object. If you're somewhere fairly dark, it's right in the middle of the constellation Cancer. It's a bit more diffuse, a little bit fewer members than M67. I believe it's younger. I would have to check that to be sure. Actually, I think from what I've seen from my own photos of it, the colors of the star kind of indicate a generally younger cluster here. And some people have said that, well, it looks like a bunch of bees swarming around. I don't know if you see that, but that's the name, Beehive cluster.
The problem is I don't see the can of Raid.
Well, that's a good thing. We need them for pollination. We need them to provide the cycle of life here in the sky, right? So the Beehive cluster, stars go flying out of it. No, they don't. Well, they do. They do go flying out of it, just not on the time scales that we can see. Right. So yeah.
And if anybody's interested, you'll see it pop up while I'm talking. But I pulled up Stellarium, and that gives you like a little bit of a finder area. Like that was saying, it's right smack in the middle of Cancer. But if you don't know your constellations, then that doesn't really give you much to go by. So looking up at my screen that has Stellarium, if it's not blinking too badly for some random reason, you can kind of get like a little finder area and see where you can find that. So,
And actually,
feel free to take
I'm
a
going to
look.
go over to David's view real quick because he has a treat for us tonight from the United States, having Saturn in view.
Yeah, first,
Woo!
I believe first CONUS continental view of Saturn for the virtual star party.
I believe so. This is our first North American view in the virtual star party of Saturn for 2013.
Wow.
It's about
Nice
15,
job, David.
It's about 15 degrees above the eastern horizon now, so it's
just-
going to be
it's-
very blurry. But
But it's still looking great, and you can almost resolve the
yeah,
rings there with it.
Ciro Villa just jumped in. M44 being 600 million years old. Thank you, Ciro.
Ciro, you're the man.
Yeah, Saturn's not above the horizon here in Arizona yet, so I'll have to wait a little while longer, but not too terribly much. Thanks for sharing that, David.
as the months go on, Saturn's probably going to be my go-to planetary target with this camera because I'm going to be losing Jupiter pretty soon. So.
Yeah, Saturn reaches opposition, meaning that it'll be up all night long, starting the first week of May. So, yeah, for the summer virtual star parties, it will be our main feature here. So by the first week of May, it will rise as the sun sets.
Tell me about these ears, Thad. What are these ears happening on Saturn?
We almost have a Galileo view.
The way they're swimming around, it looks like we need a Q-tip here in that commercial where the guy's like digging around and ow, right, and starts screaming. We need to do that with Saturn.
No, Scott, that's the matrix of leadership from Transformers. You pull on those and open it up, and then you become the leader of the Autobots.
Is that what it is? I'm going to go with the Galilean thing of ears.
Yeah, okay.
But yeah, these are Saturn's rings. Under more stable skies, would be able to resolve probably the A and B ring and possibly Cassini's division between them, right, which is caused by Saturn's moon Mimas, which looks like the Death Star. So it might inspire you to say, as Gary did earlier, that is no moon.
That is no moon.
But it is a moon. It just happens to look like the Death Star, and it clears out a region in Saturn's rings where it's in resonance with those particles and causes a gap called Cassini's division in Saturn's rings. Can't quite see it here tonight because of the seeing. We're looking through a lot of atmosphere with how low it is in the sky in Florida. But again, David's going to have a better shot than most of us being at that far south of latitude because Saturn's fairly far south on the ecliptic at this point. For most of the rest of the U.S., you're going to be looking through more atmosphere than somebody in Florida or Hawaii would. Of course, if you're in the southern hemisphere, like Peter, then you're going to get a much better shot as this comes around to opposition. One, because it's going to be winter for you, and two, because it's going to be nearly overhead. So,
I think it's still in Virgo or Libra. It looks like he's Spica up there too.
Yeah, it's kind of near the border. I mean, Virgo's an enormous constellation, so if it's not in Libra yet, it will be there soon.
It's ironic. When I was a teenager and I started into astronomy, Saturn was in Virgo then, and it's just come back around in the last few years. So I've been into astronomy for one Saturnian year.
You're getting old, David.
Yeah, that shows how old I am.
Saturn period.
Yeah.
Which and something to think about too when we're talking about the periods of things, just how long it takes to go about. And so just like the Earth has our own year, everything else has their own year and how long it goes through it. It's how we're able to measure seasons if there's any axial tilt on them as well. So going quarter around their period around the sun. And it's a little over 7 years for Saturn to go from one season to the next, which is always fun to think about, being able to get images over years and years and years and watching it rotate back and forth from our point of view from there.
And Saturn's heading toward its summer, which is a great thing for shooting the rings because it means that they're opening up more and more toward the sun. So the northern hemisphere on Saturn is heading toward its summer. We'll get a wider view of the rings, and I know that there are various astrophotographers who post their pictures to Google Plus here who have even shot the hexagon around Saturn's north pole. So there are people who've able to get enough images and get seeing good enough that they're able to resolve part of the hexagon around Saturn's north pole, which
is phenomenal.
Yeah,
absolutely phenomenal. If no one's seen it, you can do a quick Google search. I know we did an article on it probably about a month and a half ago. But yeah, it's something typically you'd have to have from the Cassini spacecraft to be able to see anything. But seeing it from Earth, I believe they were down in Australia. I want to say Australia or New Zealand is where the astronomers were that first got land-based telescopes that weren't professional observatories. and we're able to get images of the hexagon, which is amazing.
I'm trying to remember whether Mike Phillips has been able to yet. Also, I mean, he's done some amazing planetary work from North Carolina there.
Right.
Yeah, it wouldn't surprise me if he has.
Yeah, he's gotten Pluto in the virtual star party before. So that's Mike. Hi, Mike. You jerk. I'm gonna head over real quick to Gary. Some hideous thing that no one ever likes in the virtual star parties. So
yeah, absolutely, and I'm able to capture this one in all 3 color lights.
Oh, nice.
So this is hydrogen alpha, and if you look at that in the true color image, it is very, very red. And right here, you will see. Let me just copy it over.
By the way, since I see some of my students watching, this is the Rosette Nebula.
Ah, sorry.
So, no, it's okay. No worries.
This is Fraser's favorite.
Don't list it as Fraser's favorite. I won't count it.
List it as Fraser's favorite, and you can come over to Citrus College, and I'll sign off, and you'll be okay.
Extra credit.
Yeah.
This is in oxygen 3.
Not nearly as rich in oxygen on this one.
And here is sulfur.
Oh, wow.
So the sulfur's expanded a good bit away from the center, the oxygen a little bit less, and the hydrogen is still filling the thing. So I think what we're really seeing here is the evolution of a nebula that, as opposed to the one in Orion, which is still quite young, still producing a lot of new stars in the center, and so you're still getting supernovae flooding the central region with a lot of these elements. We kind of even just in the hydrogen alpha view can see that the center region of the Rosette Nebula is a little devoid of matter compared to the rest of it. And so the view in sulfur and oxygen, I think, really confirms this, that the sulfur has been pushed far out from the center regions. The oxygen is a little bit, little bit closer in. It's a little weird considering if you think about sulfur being the heaviest, it should travel the slowest. But again, if the major activity, the major recycling due to supernovae occurred earlier on this, then the sulfur would be pushed out farther because of once the stars get onto the main sequence, they're glowing with visible light, it's going to provide the radiation pressure to push the elements away. So it clears the center region out some. There's still plenty of hydrogen around, but the oxygen and the distribution of the sulfur, I think, really point to the age and evolution of this nebula when you compare it with something like Orion, where you still see all 3 of the elements concentrated fairly strongly around the trapezium.
Right. I've put hydrogen back up. I'll switch to sulfur here real quick, and you can see the transition.
So there's hydrogen.
I was going to have him put it up there. And I have an actual 3-color image that was done in the exact same.
We're gonna have an astro photo off, guys.
Well, no, it was done in the same filters that he was doing, and you could actually see the differences of where everything comes from.
Oh wow! So I'm going to go back over to Gary's real quick, and so we're looking here in sulfur.
In sulfur, yes.
All right. And then compare that over to Roy's, and you can see that this is gonna be like the golden color that you're looking there in sulfur.
Yeah, pretty much.
So you mapped sulfur as red, then, right, Roy?
Yes.
So oxygen's blue, or excuse me, hydrogen's blue, and oxygen.
Well, the Hubble palette has hydrogen as green.
Hydrogen is green. Yes. The oxygen is blue, and the sulfur is red. And then there's a huge shift to get it to more of the brownish instead of just an overwhelming green.
Mm-hmm.
So when we're talking about these narrowband filters, when we're talking about sulfur and hydrogen, the sulfur is the 672 nanometer emission line, basically, that you'll see in spectra, for example. But here we've got a bandpass filter that filters about, what is it, 3 or 6 nanometers either side of 672?
Mine are 6 nanometers. I don't know what Gary's are.
Right now I'm using 12 nanometer.
12 nanometer, yeah. So what it's doing is a band pass of that frequency of 672 nanometers, right? So it strips out any of the light that's outside of plus or minus 12 around that frequency, which is what we're talking about when we're talking about these hydrogen filters. Is 56 nanometers, I think, and sulfur 672, and the oxygen's about 500 And yeah, so it's what we use in narrowband imaging, and then we map those filters to like a false color palette. And the Hubble palette is the one they're talking about, which is usually, hydrogen and salt. I think S2, HA, and O3. I think for RGB.
Correct.
That's great. No, so you said, Gary, right now you got sulfur up. Can you pull up oxygen and hydrogen again so we can just compare it with the color?
Can. Let me see. Here comes oxygen. Okay, that should have just switched to oxygen.
There we go. So
that's a stunning image.
Then I will go back to hydrogen. Hang on, I got to finish saving that real quick.
all right, I guess I'll let you save it.
Oh, yeah.
I suppose.
Thank you.
I'll be gracious.
This is a little different hydrogen that I just took so I could save it all, but here we go. Put that hot folder and right there. Now this should be hydrogen. There we go.
Oh, there you go. Wow. You've seen the dust lanes in there are just phenomenal.
Yeah, and I'll put these up too and post links to all of these, so anybody who wishes to play, go for it.
Who wants to play with space? Everybody, everyone.
Gary, I love the fact that you're posting up your images for people to, play with and work with, because one of the principles that Pamela runs CosmoQuest by is, open science, and that's just awesome that it's like, okay, here's my images, and if anybody can make a better image out of them than I can, you're welcome to it. That's pretty cool, man. Thanks.
Yeah, that's it. I've been doing everything in Hydrogen Alpha and just displaying it. And just a few weeks ago, I thought, why don't I take these in all the different colors and put up the raw pictures. Now, normally, when I do it, I'll shoot anywhere, usually 2-minute exposures, depending on what I'm looking at. I'll do 10, 20 2-minute exposures and stack them. So I reduce the noise, I get a little better quality, but still these are 1-minute single shots, and somebody can have a lot of fun playing with these, and there's even some freeware out there that lets you combine this stuff and make color.
Right.
Yeah, Deep Sky Stacker. There's a whole bunch of them. One of the other things I was going to mention real quick for people who are citizen science junkies and might find the idea of processing images more fun than acquiring them is the Hubble Space Telescope has an image library, and you can get the images that Hubble has taken and process those and turn them into color images if that's something that people out there in Internet Plus land have are kind of dying to get into.
How long were these images, Gary?
Excuse me?
How long were these exposures?
All 1 minute.
1 minute?
Mm-hmm.
I was going to leave if you can leave your Hydrogen Alpha up there. I mean, if we got time here. I did a 5-minute Hydrogen Alpha, and I was going to show you the comparison with your hyperstar with my non-hyperstar.
Sure.
Just showing off, huh?
Well, his is so much better with the hyperstar in it.
Well, in this one I didn't stretch real good. I like to make it a little bit darker around the edges, but I did it real quick.
Well, and while you're pulling that up here, Roy, because I think it'll be the last thing we do here tonight, I'm going to switch back over to David to take our glimpse again at Saturn.
A very blurry glimpse.
Hey, it's a glimpse. It's still looking fantastic. I think
I'm starting to see a little bit of A ring versus B ring. I don't know if I'm filling it in mentally because I know it should be there, but I think I'm starting to see a little bit of difference in coloration between the inner and outer ring.
I can see the shadow of the globe being cast back on the ring down to about the 5 o'clock position there on the frame.
Right.
Mm-hmm.
Oh, yeah.
Yeah. I think they're about 17 degrees wide, the rings this year, roughly. So
we still have another, I think, 2 years to go until they're fully open?
Yeah, they're getting wider every year till 2017, 2016, something like that.
So it was 2007 when they were gone.
Yeah,
right. So 7 years, 2014, 2015. Yep.
Yeah.
Hey Scott, before we get going, do we have time to answer one more question for a viewer?
I think we have one more question. What's up?
Okay, so somebody was asking, and this is probably a good question for Thad, is there a particular staggering order of the elements being released from a supernova, or are they just released together and travel at different speeds, probably related to their mass, or something like that.
So this is the weird thing in the physics of a supernova, that what's going on in the very deep interior of one of these ultramassive stars is it's producing heavier and heavier elements as it goes. And the trick is, with iron, you cannot get energy out. Every element lighter than orange, than orange. What the heck am I looking at? Am I thinking of the Netherlands? No, I don't know. But anyway, any element lighter than iron, when it undergoes fusion, it releases energy, and that energy helps to keep the star up. The day it starts making iron, it dies. And so all of that iron now disintegrates into protons, electrons, that then get jammed together to make the neutron star, or potentially black hole in the middle. So what you've got outside of this, you've got shells. So you have a shell of like sulfur, silicon, neon, oxygen, carbon, helium, and then the hydrogen on the outside. So when the shock wave goes out through the middle, it's forcing elements from the inside into elements in the outside. Because you're putting energy in from that shock wave, you can make heavier elements. So the first things that are going to go, I mean, you'd first get this shell of hydrogen expanding away from it, and when we talk about a type 2 supernova, like the one in M65, that's what we're seeing, is that hydrogen lighting up with this extra energy from the shock wave. As far as the dispersion of other elements go, the flow gets extremely turbulent inside an expanding supernova. So to be able to say that it's, the shell's kind of expanding out like this, you can't do that. The flow is extremely turbulent. They're all getting mixed up in there. So, yeah, it's a good question, and it's a difficult one to answer, largely because of the turbulence that occurs in a supernova explosion, that you end up mixing the shells together, and so it's no longer this kind of neat layer of denser elements on the middle, less dense elements on the outside. It all gets mixed up in the explosion.
But does it weigh more than a duck?
Does it float?
Who are we putting on trial here?
Don't know.
There's some people on the moon, and
how do they weigh compared to very small rocks?
Churches float.
Well, thanks for taking that question, Thad. I really appreciate it, and I'm sure our viewer does as well.
Yeah, Peter?
Scott, I need to drop off, so I'll say hooray, and thanks for having us today.
Thank
Peter,
you.
Thanks for joining.
Good night, Peter. Good to see you.
Talking about citizen science, I've nominated citizen science as one of the planet names in the Uwingu exoplanet naming competition. So if you want to go in and vote for that, that'd be great. So, reflecting citizen science value in a lot of science research today. So Uwingu's got a exoplanet naming competition going on at their website at the moment. So if you want to go and vote for some planet names, that'd be great. Anyway, got to go. See ya. Thanks.
Good night,
Thanks
Peter.
again, Peter.
Later, Peter.
All right, Roy. So let's see what you got here. So this is your 5-minute, you said?
That's a 5-minute hydrogen alpha, and you can tell, I mean, even under Gary's 1 minute with the his hyperstar lens, with the focal ratio, he pulls in way more light than I do.
So right now we're looking at Roy's. I'm going to hop it back over on Gary's.
And it's flipped.
Yeah, they're not the same orientation.
I heart hyperstar.
Yeah.
Well, since we were talking about the bandwidth of this filters, I'm getting better results with the 12. I've got a 3 nanometer filter, but after talking to Dan Goldman, right? Yeah. As you get a faster F ratio, it actually changes the center frequency of the filter. So at F2, I'm a little off of hydrogen, so I went with the 12 nanometer, and I get a little more light.
Okay.
Just a thought.
Didn't know that.
Thank you. I will need that for when I start shooting narrowband.
He's a brilliant man if you get a chance to talk to him.
Okay.
Awesome. Well, it looks like our time is up. We've been here for a good hour, and I've been in Hangouts all day long, so I'm kind of tired. But I do wanted to thank everyone for your questions, comments, suggestions, and our comments on Twitter, Google+, YouTube. You guys are awesome. Thank you for watching. We've actually had quite a big turnout tonight with our viewership, which is great. Let's head on over to David. Thank you, David. Where can we find more of you on the inner tubes?
Universe Today, Astro Guys. I've got a few other articles coming out some other places, but those are my 2 main sites.
Very nice. And follow him on Twitter. He's a lot of fun on Twitter.
He's very active on Twitter. I love seeing all the tweets from him. Lots of history stuff as well as history of astronomy as well as astronomy stuff. So
Thanks.
Gary, my friend, my neighbor-ish.
Absolutely. And Scott came over and helped me fall through a ceiling. So
Hey, no, I helped after the fact. I tried pulling you down.
oh, yeah. How do you push up? And just, I'll make a comment here that I may not post my photos until tomorrow, since we've got the grandkids at the house and I've got to go pay some attention to them.
Oh, I suppose you can love your grandkids.
I know. It's
the internet will wait.
Yes.
The anticipation's worth it, though.
All right, everybody.
Where can we get more of you, Roy?
Yeah. Oh, I'm sorry. I thought you said Ray, not Roy.
Roy.
That's okay. There's somebody at work called Ray, and they always get us confused. So the only place you can get more of me is on my Google Plus page.
Fantastic, and yeah, you post some great stuff on there, Roy. So thank you for joining us, even with the winds and opening your observatory for us to show off. It was great.
Yeah, winds were a little high tonight, but I chanced it.
Well, we appreciate it. And Ray.
You can usually find me on Google Plus. Not hard to find. On Twitter, I'm known as at Dear Astronomer, where my shenanigans are cheeky and fun. Additionally, just wanted to remind everybody that if you're really into citizen science and you want to help out, as Scott was mentioning earlier, we probably didn't want to get on this topic too much, but with the NASA Education and Public Outreach sequester, there's going to be some ramifications of that. So people, if you want to see cool stuff like this and help out with citizen science, be sure to drop by cosmoquest.org and see what they've got and check out everything that's going on, because we could wind up really needing everybody's help if things keep continuing in the pace that they're going with NASA.
No, absolutely. And yeah, we appreciate everyone's support, whether it just be with spreading the word or anything like that. We do definitely appreciate it. Because this is for all of us, not just us being fun and nerds, but we really enjoy being able to spread out the science to everyone. Dr. Thad Szabo, my other friend and kind of neighbor.
Kind of neighbor, yeah. So I'm teaching astronomy and physics at Cerritos College. You can find me on Twitter at AstroThad, and a lot of time here on Google Plus and posting to the space community and to my own feed if I don't feel it's really super, like for the space community. So,
all right. Well, again, I'm Scott with KnowTheCosmos.com from Astrosphere New Media, CosmoQuest, all over the place. I am Bald Astronomer on Twitter, and it's been your virtual star party. Thank you again, everyone, and we will see you next week.
Yeah, bye.
Good night, all.
Good night.
Good night.
Source catalog is a core SDB. And then common name, what does that say? I'm looking up in my common non-stellar. So it's
Sure.
core
IC405
SDB.
or Caldwell 31.
Okay.
And for those who are interested in trying to find the Flaming Star Nebula on themselves, I've pulled it up in Stellarium. It's in Auriga, as opposed to Aruba. It's in Auriga.
Or arugula. It's the salad in the sky.
Ooh.
okay, so this is it. It surrounds the irregular variable star AE Aurigae. So, so there we go. So there is a variable star in the middle. So that would add kind of maybe a bit of flickeriness to it. But I've got to see is there a period on that variable star? Because that would tell us how long to expect one flicker of the flame to last. But it's an emission and reflection nebula, so right now, because of having hydrogen alpha, we're just getting the emission portion. But if we could do a color photograph, like with a color CCD or with a DSLR, then you'd be able to see some bluish regions from dust in there as well. So this is actually fairly bright. That's surprisingly bright. It's magnitude 6, meaning that if you were under dark enough skies, like somewhere like Death Valley, for instance, you'd probably be able to see this naked eye.
That's really awesome. So just a quick reminder, everyone, that if anyone has any questions or comments or even requests, you can go ahead and leave them in the event page here on Google Plus or out on any of the shares. So Also, if you guys could, please feel free to share out the Hangout to everyone in your circles to help spread the astronomy out there. We'll also be on Twitter using the hashtag Star Party. So if you want to make any of your questions or comments, we'll be out there. And also on YouTube, we'll be able to see those as well. So I'll be checking out those comments and questions. And feel free to make some requests. So moving along, we're going to go over to Peter. And what do we have here, Peter?
So one of our favourites, M1. So just got to zoom in on.
Because he's in Florida for one, but also
Yeah,
since you're looking through more and more
We're
atmosphere.
beginning to start to look through more air mass now. It's only about 20 degrees above my local horizon here. We'll probably, in a few more virtual star parties, we probably won't be able to get Jupiter, at least not from this location.
Right.
And I'm in the Eastern time zone. So.
Eastern time zone.
Yeah.
Like daylight savings time.
Actually, it's daylight save. And somebody corrected me the other day. It's actually daylight saving time.
Oh.
I actually wrote in a post with the daylight savings time, and I had a commenter say that actually it's daylight saving time.
Actually.
Yeah, it's kind of one of those things like ATM machine and PIN number.
Right. All right. Well, I'm going to move over to Gary's view here. And what do you have for us tonight, Gary?
This is the Flaming Star Nebula, and I don't think I've ever imaged that before. It just came up in a club meeting that we had Friday night, a guy that was pointing out things in the sky, and I don't recall having seen it, so I thought I'd point at it and put it up here. And somebody like Thad can tell us what it is.
Someone like that, or Thad himself.
Or someone like me. Can I find my clone around here somewhere? So Flaming Star Nebula. Actually, I don't know how much I've known about this one. But again, if we're shooting with H-alpha, then what we're seeing here is hydrogen. And now we know, because of Planck, that hydrogen is more of the universe than we thought before. Instead of thinking it was a little less than 4% of the universe, now it's just a little less than 5% of the mass in the universe is hydrogen. All getting lit up by a star here in the middle. And I'm guessing with the idea of flaming star, that this is most likely some sort of variable star bit in the middle, maybe. Again, not terribly familiar with the object, but I'm thinking when I hear flaming that I'm thinking variable. Or is it just that it looks like a flame? Is that it kind of looks a little bit like a flame here?
Yeah, it kind of does.
I couldn't find any other designation for it. Let's see.
IC 405 is what it's showing in Stellarium for me.
Okay, because I'm showing it.
Hi, everyone. I am Scott Lewis, and this is your virtual star party for March 24th, 2013. We have a great show for you tonight. As showing earlier, we have David Dickinson out of Florida showing us Jupiter.
Okay.
And we also have with us Gary Ganella out of my backyard. Well, close enough, right?
Close enough.
And we also have Peter Lake with us from Australia
Hi,
and
Scott.
New Mexico, right? At the same time?
Yes, correct.
Quantum Peter. Awesome.
On my lunch break, yes.
On your lunch break, even. And we also have we have Roy Salisbury.
Hello.
Hi, Roy. And with us with commentary tonight is Ray Sanders driving Stellarium.
Hi, everyone.
And our PhD astronomer, Dr. Thad Szabo from Cerritos College.
Good evening.
Hi, everyone. So it's been a crazy week. We've had a lot of hangouts so far with science today for Science Sunday. It's been really fun. And we were going to stay on the same task of keeping our virtual star party, even though Fraser is out invading the United States somewhere. He's somewhere in the northwestern U.S. We haven't tracked him down yet. So if anyone sees a tall, balding Canadian, go hunt him down.
Can we set up something, Scott, kind of like the Santa tracker? We can do the Fraser
We totally
tracker.
should. Absolutely. Go. This is Fraser, eh? And we'll just find him on Twitter. It'll be great.
Shouldn't you just look for like a large convergence of social networking, like pings and packets that aren't going toward like Microsoft up there or something? Then it's got to be Fraser. Right?
It must be Fraser. You know, there's many bags of milk references and Mounties, and we don't know what's happening. But
Well, he's from the wrong part of Canada to be bringing maple syrup, right?
I don't know. I'm sure they have maple syrup somewhere in Vancouver. So looking here, I mean, right now we're pulling up Jupiter first with David Dickinson because it's setting, and So it's going to look a little bit more wavier and soup.
That a little bit for you. Here's my zoom button here. So it's a Crab Nebula. So it's a lovely, the first one in the Messier series. So it's
Very nice.
it's very good.
All right, so this is a supernova remnant. So we had a massive star come to the end of its life it would have been about 7,500 years ago. But because this object is 6,500 light years away, follow the math here, that means that supernova showed up in our sky about 1,000 years ago. And the ancient Chinese astronomers recorded it, Arabic astronomers recorded it. People in Europe went, this doesn't feed me or keep me alive. I'm going to go back to plowing fields.
Right.
But it's apparent that probably some of the tribes of Native Americans in the Southwest U.S. also did a kind of cave painting of this bright star near the moon. It was visible during daylight for at least a month when it first blew up, and now 1,000 years later, this is what we see, this expanse of hydrogen and other elements that have been dispersed throughout space because of this massive explosion. There's a neutron star buried deep in there somewhere, and so we get pulses from it as a pulsar. So yeah, pretty amazing object, and again, it's a recycling method. This is how we get elements back into the universe to potentially make new planets, new life, and just kind of continuing the cycle here as long as we have these ultra-large stars. Nucleosynthesis, and not just Big Bang nucleosynthesis. Right? We get elements heavier than oxygen this way. So.
Right.
Yep. Now I'm going to throw up. You mentioned supernova, so. Very quickly throw up M65, but it's only 15 degrees from the moon and just can't do it. So where
moon?
if you just I could probably zoom in, but you can't even see that it's a galaxy. So it's just not doable. But I think Roy's got one from last night. He's going to share with us. But these Type 1 and Type 2 supernovas go off almost every day now. I think, Tad, there's about 400 a year detected in the Central Bureau for Astronomical Telegraphs. I think that averages out at about one star blowing up every day, which is quite amazing.
Right, and I mean that's in the magnitude range where we do frequent scanning, and from Earth's surface, the cutoff is typically about magnitude 22. So there are likely far more going off, but because of even with no light pollution whatsoever, you have limitations due to air glow, aurorae, just other effects from having an atmosphere that limit the faintest ones we can see. If we had, say, a dedicated sky survey telescope in space, we'd be seeing hundreds per day, most likely, from some of the most distant objects in the universe. But again, that we don't have any telescopes in space that can survey that large of the sky at that deep a magnitude and still give us good photometry. So, future project.
More science, please.
More science.
Science.
So Thad, real quick, what's that space telescope that does the X-ray and the gamma, where it detects the X-ray and gamma ray bursts and then slews to the location?
Swift.
Swift. Okay.
Yep, Swift.
We just had a presentation on that Friday.
Nice, yeah. It's amazing what that's found, though, and also just a little bit of the history of even finding gamma ray bursts, that it was an artifact of the Cold War, of U.S. satellites monitoring the Earth's atmosphere and monitoring the Earth's surface for activity from the former Soviet Union, and they're like, hey, there's bunches of gamma rays coming in burst from the opposite direction from the Earth. And so that was the first indication that you had these incredibly energetic processes that were flooding space with these essentially beams of radiation from